Okay. For some reason, I cannot get the third page of this guy to post into here. So we're going to look at it here for a second, and then I'm going to do some work on the Scribbler page here. But remember, we just did these limits here. Now we're down here on the third page, and we've got limit delta x goes to 0 of all of this gigantic hot mess up here. I told you, if you don't like looking at delta x is just a variable all by itself. It's not the same thing as x. It's a very different variable. Just make it an h. If you don't want to deal with delta x, make it an h. So we've got 4x squared minus 3x plus 8. So let's write this out here. We've got minus, oh, come on. Minus 4x squared, I forgot it already. Minus 3x plus 8. Minus 3x plus 8, which means over here we've got, this is never going to fit, 4x plus h squared minus 3x plus h plus 8. Okay, there we go. And then we had the limit out front here. So pardon my, so h, I turned it into an h. Pardon my crushing that down there, all over h. Now really this is a derivative in disguise, even though you don't know it, maybe. It's the derivative of 4x squared minus 3x plus 8. But anyway, let's go ahead and do this. We're going to expand out all this junk because well, first you plug in 0 for h, and we're going to get 4x squared minus 3x plus 8 minus that exact thing. So the top is 0. Over h going to 0 just becomes 0 as well. So we get 0 over 0 in indeterminate form. The h's are going to cancel out eventually. Let's see what happens. So we're still going to have, let's do it then here. I wonder about the limit as h goes to 0 of squaring this out is going to give us 4x squared plus 2xh plus h squared minus 3x minus 3h plus 8 minus 4x squared, what, plus 12x, no, that's not 4, not in there, plus 3x, plus 3x, oh my god, 3x and then minus 8, there we go, and all of this is over h. So, when we change color here, we're going to start canceling things out. Minus 3x plus 3x goes away. Plus 8 minus 8 goes away. Over here, we're going to distribute this 4 and get 4x squared. So 4x squared, this is going to become an 8, and this is going to become 4h squared. So he's not here anymore, we distribute it. And 4x squared minus 4x squared goes away. So what's going to be left is the limit. We're changing colors again here for some reason. The only thing that's left up here is 8xh minus 3h. Is that it? That's it. Over h. And now these h's, since they're everywhere, can divide out. And since there's no more h's, the limit going to 0 doesn't really matter anymore, and we just get 8x minus 3. Oh, I forgot something. I'm sorry. The 4h squared was in there. So that should really be out here. 4h squared plus. But one of these h's is going to cancel, so really we get 4h plus 8x minus 3. And if h goes to 0, you get 8x minus 3. So the h goes away anyway. That was a bad mistake on my part. I apologize. Okay. Let's clear this page. What's next in this? Okay. Prove sin x. No, this is a mess. Sin x cosine x minus secant x is continuous at x equals negative pi over 3. So sine cosine minus secant. So I'm going to prove sin x cosine x minus secant x is continuous. So that's f of x. Continuous at x equals negative pi over 3. Well, when you're doing these, you really don't have to think too hard. These are all the same kind of problem. Remember, for continuity, you're checking 3 things. The function's defined, the limit exists, and they equal each other. So, just to check this real quick. Sine x is continuous everywhere. Cosine x is continuous everywhere. So sine x times cosine x is also continuous everywhere. Secant x is continuous everywhere except for where cosine is 0. Cosine 0 with the pi over 2, 3 pi over 2, 5 pi over 2, just all the pi over 2s. So since negative pi over 3 is not a pi over 2, this thing is going to be continuous. That's easy. So what we're going to do is say that we're going to check our steps. Number 1, f of negative pi over 3. We're just going to plug it in and show that we get an answer back out. Sine of negative pi over 3 is the same thing as sine of 11 pi over 3, which is negative root 3 over 2. Cosine negative pi over 3 is 1/2. And secant of negative pi over 3 is the reciprocal of cosine pi over negative pi over 3, which is 2. So our answer is negative root 3 over 4 minus 2, which is a number. It's defined there. Check. Number 2, show that the limit exists. Well, in this case, I don't even need you to do anything crazy. Just x is going to negative pi over 3 of f of x. Now, if this was something like weird, like a piecewise function or something, you can go ahead and do like left side limit, right side limit, and all that. But in this case, we can just kind of plug this in and get an answer back out, and we're going to get the same thing we just got up here. And maybe you're thinking this doesn't make any sense. What's the point of this? The point is that you memorize how to prove something continuous. Now, we're looking at an easier function here. Even though there's trig in it, it's an easier function, trust me. That's why this seems like it's such a dumb waste of time, because it is a waste of time. We know it's continuous there. We know sine, cosine, and secant look like. We know where they're continuous. This definition we're going through, steps 1, 2, and 3, is very useful when you're trying to work with a very complicated function. So just be thankful that, you know, on a test in Calc 1 that you're not getting a complicated function. You're getting, again, even though it's trig, a relatively easy function. Now, the limit, they equal each other here, and I really didn't do any magic. I just kind of plugged in. X goes to negative pi over 3 of f of x equals exactly f of negative pi over 3. And that is really our definition of continuity. This is the big one. This one gets the star. That's what we need to happen. So anyway, if I say, or if a teacher asks you prove that it's continuous, you're going to do these 3 steps, ending with this. And if all 3 of them work out, it's continuous. You're done. That's all the work you need to show. Excellent. No, we don't do that. Yes, do that. Okay. Alright, now we've got another limit. Find it. If it doesn't exist, explain why, show your work. Okay. X is going to 2, x squared minus 5x plus 6. So we've got the limit. X is headed towards 2 of x squared minus 5x plus 6 over x squared minus 5x plus 6. Excellent. Well, we talked about functions like this. When you have the absolute value of something and you're dividing it by itself, it can only equal 2 things. It can only equal 1 or negative 1. They're the only 2 possibilities. Because if you plug in an x value and the numerator is positive, or x squared minus 5x plus 6 is positive, then the absolute value doesn't do anything at all. For instance, if we plug in 10. If you plug 10 into this function here, you get 100 minus 50, which is 50 plus 6. So you get 56 divided by 56. That equals 1. If you plug in, say, that's going to be hard for me to do. It has to be something between 2 and 3. So like 2.5, I guess, 5 halves. If you plug in 5 halves, you're going to get 25 fourths minus 25 halves, which is what, negative 25 halves, plus 12 halves is negative 13 halves. Okay, I think I did that right. But either way, you're going to get a negative number. So it's absolute value of negative 13 halves over 13, negative 13 halves. Well, the absolute value is going to make this one up top positive. When you're dividing, you still get 1, but now one's positive, one's negative, you get negative 1. They're the only 2 possibilities. That's all that's going to happen here. So all we got to do is figure out what's going on at 2. That is our whole question. So let's get rid of this. Clear this up some. Okay. Something we can do here easily is factor this. That might help us. So let's take the limit. X is going to 2. X minus 2, x minus 3 over x minus 2, x minus 3. There we go. We don't know what's happening at 2. So really, since this is kind of a simple problem here now, it's only 2 things we multiplied up top here, we can look at the left side and the right side. So I'm just going to change this to the left side limit. X is a little bit less than 2. Okay. What's it going to equal? Well, again, we know it's either 1 or negative 1. at 2, when you plug in 2, you get 0 over 0 here. So it's undefined, okay? But it's either headed to 1 or negative 1. It either always equals 1 or always equals negative 1 on one side of 2, like super close to 2. So let's figure this out here. These x minus 3's actually are just going to cancel out. We don't really care about those because the point in question is 2. When you plug 2 into x minus 3, you're going to get 1 and 1. Or if you plug in a number close to 2, you're going to get just whatever. They're going to cancel out. They're both going to be the same exact sign. So really we don't care about those. So we can essentially just look at this. Now this is even easier. If x is a little bit smaller than 2, then x minus 2 is a negative number. Something smaller than 2 minus 2 is negative. Up top, we're going to get that negative in an absolute value. Okay, so really this is going to equal, now again, we're thinking about numbers super close to 2. We're going to get a number super close to 0 up top. It's going to be negative, but the absolute value is going to make it positive. And on the bottom, we're going to get that negative number, and there's no absolute value to make it positive, so it's going to be negative. But they're both going to be the same number. Doesn't matter what number we're thinking about. They're both going to be the same exact number. A positive number divided by a negative number, the same number, well, that's just negative 1. So from the left-hand side, it equals negative 1. And maybe you can guess what's going to happen from the right-hand side. Same thing, the x minus 2's or x minus 3's are going to cancel out. We don't really care about those. If x is a little bit bigger than 2, well now, x minus 2 is going to be positive. And they're all, again, same number on top and bottom. They're both positive now, so we're going to get positive 1. Well, we're going to say this limit, the original limit, does not exist. And the reason is, here's all our work. You're going to write this. The right-hand limit does not equal the left-hand limit. They're not the same number. That's why it does not exist. That's all I need to show. Cool. Let's do the last one of this page, number 8. Does limit x goes to negative 1 of f(x) exist? Explain. All you need to do here, first off, 4x plus 10 is continuous. 2x squared plus x plus 5 is continuous. If we want to check at negative 1, well, that's where the split is. So, of course, that's what I'm going to ask you. What's the limit as x goes to negative 1? So let's see where 4x plus 10 is headed. Well, when x is negative 1, 4x plus 10 is equal to 6. All right, so let's go back over here. Let's clear this page. There we go. So the left-hand limit, as x is going to negative 1 from the left side of f of x, is going to be 6. It's approaching 6. It never gets to 6 because it doesn't equal negative 1. It's just less than negative 1. But again, you can get as close to negative 1 as you want. And as those numbers are getting closer and closer and closer to negative 1, 4x plus 10 is getting closer and closer to 6. Let's check the right-hand limit. As at negative 1, this is a parabola, and it's going to equal to minus 1 plus 5. That equals 6. Oh man, this is so exciting. X goes to negative 1 from above. F of x, that equals 6. Since that equals the right-hand limit, we can write that out here. You hear my phone ringing, I'm very popular. I'm disregarding it for you. Since left hand equals the right hand limit, the limit exists, and it equals 6. So you would write limit in cursive for some reason as x goes to negative 1 of f of x equals 6. Okay.